going with this, so we've got a couple of things. We've got Pythagoras we're going to look at, and trigonometry. Why I blend these two together is because you can only use them for right angle triangles, okay? With Pythagoras' theorem, it actually a squared plus b squared equals c squared. It's a really cool concept. It typically happens with like 3 squared plus 4 squared equals 5 squared, because you've got 9 plus 16 equals 25, and you can see they both equal 25. Why I really like this one, it proves off the I suppose the understanding of what Pythagoras' theorem is, and it was a really good discovery. So it comes from a right angle triangle. When we talk about squares, if we talk about this being length A, this length B, and this length C, if we talk about a square, if I say, well, what's 3 squared, you'd say it's 9, but I could also say that equals 3 by 3. Now, why do we call it squared? Is because it actually makes, if you go 3 by 3 and you want to show that as a shape, that's a 3 by 3 square. You could say the area of that is 3 squared. So we call it squared because when you times something by another thing, it can actually make a square. So the area of this, I could say, is 3 squared, right? So when we talk about a squared, it actually means the area. We're actually talking about this square, a squared. When we talk about b squared, we're actually going b by b, which would make a square. That's why we call it squared. So the area of this plus the area of that equals the area of this one. And that's why you'll see this image as one of the proofs. So when I see this 3, 4, 5, I don't really see 3, 4, 5. I mean, I do. I sort of see 3, 4, 5. But what I really see is I see 9 as the area. And I see this as the area of 16. So that means that the two areas of these need to equal this area for it to be a right angle triangle. And they do. This is 25. Another one that I could see is you've also got 12 and 5, which makes 144. And that makes 25. So that, if it was a right angle triangle, the area of this side would have to be 169. Square root of 169 is 13. So that's another Pythagoras' triangle, 5, 12, and 13. So really all you're doing here is a squared plus b squared equals c squared. These two areas need to add up to that one. How do we do it mathematically? Well, let's just say we wanted to know what that length was. If we knew this was 3 and 4 and we wanted to know what this is, well, in this case, you're just going to go, well, these two squares added together, and then you're going to square root it, because the square root, once you get the area, you've got to square root it to find the side length. So I know that the area is going to be 9 and 16, so the area of this would be 25. If I square root 25, it's going to give me the side length of it. So mathematically what we do is we actually go like this. A squared is 3 squared. So what you're actually doing now is we're saying, hey, the areas of the square is 9 plus 16, which equals 25. The total areas of c squared has to equal that. Then you square root it. Why we square root it is 25 is to get the side length. And the side length of it must be 5. It's got to be positive 5 for it to exist. So it is 5. On your CAS, though, you'd obviously do this a little bit differently. You're just going to sort of come in your calculator, go into your main, and you can do it all in one. Bring up your keyboard, do your square root. Obviously, if it's c squared, a squared, if it's a squared plus b squared, you're just going to do the square root of, we're going to go 3 to the power of 2 plus 4 to the power of 2. It executes to that, and you get 5. So you can do it. It's really quite easy. So that's one way you can do trigonometry. Remember, obviously, Pythagoras. The other one you just got to be careful of. You just got to identify which one's the hypotenuse, and this should be old news for you, I hope. So obviously, you know, if you've got known the hypotenuse and you want to find another length, this is the right angle, you're going to have to minus the area of the hypotenuse, because obviously these two areas equal that. So that area minus that area would give you the one left over. So that is going to be the square root of 5 squared minus the square root of 4, which would be 3. And that's how we get there. So, and that would give you the area of, let's just go with a squared. Okay, so that's what we're going to do. Hopefully that's okay for you. That was just a quick review on Pythag. Another thing I will show you on the calculator, and this is also handy for trigonometry as well, what you can do is you can come into your geometry feature. Now, I would get you guys to use this, but not all the time, because you still need to know how to do things manually and understanding. You can actually draw a triangle up here. When I draw the triangle, and this function will save you a lot of time, If you tap on this length, I'm going to make that, let's make that, and you go across here. Let's make that 5. Put in 5 in your keyboard. Lock that in, Eddie. No, no, let's not put in 5. Let's put in 4. I'm going to make a right angle triangle. This, I know this, if I tap on this line and this line, I know that this is a right angle here, right? I'm going to do this. That is 90 degrees. I'm going to put in 90 degrees, lock it in. I also know now that this length here is 5. 5, whoops. That in. So now I've got everything locked in. Once you've got enough information locked in, you can actually find out the length of thing. Click on that, it's got a length of 3. I can even find out the angle here, if I like, 53 degrees. I can find out this angle, 36 degrees. If I want to find out the area, I just tap on all 3. Notice how it changes to an angle, 6. So I know the area of this is 6. So this is a really good function, especially where we're moving on to next with trigonometry. So trigonometry for right angle triangles, we use the rule SOHCAHTOA. I like to write it like this. And what we do here is we either use this to find an unknown length or an unknown right angle, an unknown angle, I should say. So this you can only use for right angle triangles. If you've got an angle here, opposite, adjacent, hypotenuse is always opposite the right angle triangle. So if I had a question, and we're given a triangle, and I know this is 30 degrees, and this is 4, and I said, hey, what's this length and this length? Well, first of all, we've got to identify I've got the opposite, and I want to know my adjacent, opposite, and I want to know my hypotenuse. First of all, we'll try and find our hypotenuse. Well, I've got an angle. Notice these ones are where you get your angles. So you're always going to use sine, cos, or tan. So I've got opposite and hypotenuse. That relates to sine. So sine 30 is equal to 4. That's not 40, that's just my opposite, right? Opposite over hypotenuse, x. I can just put that in my CAS, which is going to be x equals 4 on sine 30. One really important thing here, guys, on the CAS is we're always in real deg. We're not dealing in gradients or degrees, you'll get the wrong answer. Really important. You always set your calculator in real degrees. You always want to be checking that. So, bring up my keyboard. I can just type in, I believe, this one. We go to trigonometry. We're going to go sine. We're going to do 30. We need to be in degrees because we're dealing with degrees. That's why I've got to do degrees. Equals 4 on x. Highlight, or I could have done interactivity, advanced, solve for x. It's 8. So you can get that to 8. Alternatively, I could have just gone 4 divided by sine 30, which is going to get the same thing. I just typed in the whole equation from the start. You get 8. So I know that's 8. Don't forget about units. If it's centimeters or things like that. If I want to find out this length, obviously, this is my angle I know is 30. This has to be a right angle, by the way. So that would then be cos, because I've got my adjacent, opposite, so it would be tan, opposite and adjacent. So I wouldn't use one that you already found, especially if it rounds off, unless it says, using the hypotenuse that you found in part A, find now the adjacent. I would always just use the numbers that they're given. So that's tan 30 equals opposite 4 on x. Come back up in here. Let's just change this to tan. That equals 6.9 to 2 decimal places. That would be y, by the way. Whoops. 6.9. Now, how can I do this on my CAS? Now, you can do that. Alternatively, you'll love this one if you haven't seen this before. You can also go back into geometry. Edit, clear all, hit OK. I can, again, select to draw a triangle. Click and drag it out with your stylus. Put in my angles that I know. Go across here. Lock in 90 degrees. Lock it in, Eddie. Oh, and I know this angle is 30. Lock it in angle. Eddie. And I know that this is 4. Lock it in. What's the length of my hypotenuse? 8. What's the length of my adjacent? 6.9. What's the area? 13.885. What's this angle? Well, this is obviously going to be 60 because it's 90, 30, obviously 60. Total triangle adds up to 190. So that's how we use SOHCAHTOA. One other thing I will show with SOHCAHTOA, which I should, just to tick off all of the boxes, is sometimes you're given a right angle triangle and you're asked to find an angle. Let's just say I want to know this angle and I want to know this angle. And we're given 3 and 6. So here I could use Pythag to find out that one, but really I'm given if we look at this angle here, this is opposite and this is adjacent. So to find out that, tan uses TOA, tan, opposite and adjacent. Tan angle equals opposite on adjacent, TOA. What's going on there? 3 on, why is it not writing? Do a new one. What do we have? We had 3 on 6. Three, 6. Sorry, my stylus just went all stuffed. Okay, so if I want to first find out this angle, that's my opposite, that's my adjacent for this one. So that's going to be tan angle equals TOA, opposite over adjacent, 3 on 6. Now remember when you do this, then you do the inverse of tan to the -1. That's not to the power of -1 though. Some people do get that wrong. I don't think you guys would. So all you got to do in your calculator now is just go to menu, main, pull up your keyboard. There's a trigonometry function in here. You're literally just going to do this tan because that's going to give you the angle. So whenever you need to know an angle, you need to use these ones, sine, tan, or cos, if it's a right angle triangle. And that's going to be 3 on 6. And then that equals 26.5 degrees. And you won't need to convert to minutes or anything like that. 25.6, I think I did that right. If I want to know what this angle is, I mean, now I could just go, well, add these two together, 180 minus the sum of these two, but let's just use this one to see what it is. This is different. Now, from this angle, this is now my opposite, and this is my adjacent, because this is still my hypotenuse for both of them. So when I'm working from here, TOA, I'm going to do 6 on 3, okay, because this is my opposite, that's my adjacent. So that's a bit different. So that would be different, which would be 6 on 3. And therefore, I can see that my angle for that would be 63.4 degrees. 63.4. 3.4? Yep. Doesn't seem right because the other one was around the wrong way. Maybe I didn't write that one down right. 3 on 6. What was my other one? It was 26.5. I did stuff that one up. Sorry. That makes more sense because now they add up to 90 degrees. Pretty much with rounding error. That would be 0.6. Okay. So that is pretty much SOHCAHTOA. The last thing that you do need to know is about elevation, angle of elevation and angle of depression. When we're talking about elevation, we're talking about the angle it makes with the horizon. So a straight line going straight out, okay? So why we call it with the horizon is because if you're looking this way, that's the angle. If I looked up at an elevation, you know, if someone elevates you, it's the angle measured from the horizontal line. So that'd be like 20 degrees. If I'm talking about angle of depression, well, when you're depressed or you're feeling not good, you're looking down. If it was like 30 degrees depression, you're looking down and it's measured from here. Now, don't forget, if you've got that measurement of 30 degrees, I know that this is 60 in here, and sometimes that can help a bit when I need to find different angles, okay? So that can help. Say if this is a length 2 kilometers and I knew this was like 500 meters, don't forget to make sure units are the same. If we had like a little boat out here, right, it's sailing away, you can use that triangle. Or you could come up here and use this triangle. You could use 30, make a right angle triangle here, make this 500, and that would still be 2,000. So you can still find out, like, you know, how far away it is on this light, sign of light, or if you want from the base of cliff, you might not know that. But you've got this and this, and you'll be right. So elevation, looking up from the horizontal, depression, looking down. That is it. I'm not going to